Welcome back to the Deep Dive, where we take your technical research and notes and really try to distill them into actionable knowledge. So today, you might be gearing up for a new Haskell project. And, tools like Cabal are brilliant for bootstrapping a code base.
Oh, absolutely.
But that initial setup, it throws a handful of deceptively simple questions at you. We're diving deep into those first choices, how to structure your directories, and maybe more importantly, how to define your language dialects.
And that's really our mission today. We've gone through a bunch of technical notes on the Cabal init process, and we're focusing on those points where just, hitting enter for the default might not be the best strategic answer.
Right.
We want you to move past the defaults. By the end of this, you'll get the subtle implications behind choices like app versus X and the pretty high stakes involved in matching your library's language standard with your executables. It's all about making informed choices right out of the gate.
Okay, let's unpack that. Let's start with structure, because that's the first thing you see, right? It defines the whole layout of your project.
Yep.
When you initialize a package, Cabal asks where the main application code should live.
Yeah.
And you get, 4 choices? 1 is app, 2 is exe, 3 src, exe, IDEA, and then other. The default, of course, is app.
And that default app it's excellent for the vast majority of people who are just building one main program from their package. It's the modern way, it's clean, and it keeps your library code separate from your executable.
But here's what the source material pointed out that I found confusing at first. When you actually bootstrap the project, the directory structure, it looks identical whether you pick app or exe.
Right.
So if the files are in the same place initially, what's the fundamental difference? I mean, why should we even care?
It's all a question of scope and mental modeling. It only really becomes critical as your project gets bigger. If you pick app, you're sort of mentally committing to a single executable. But if you know from the start that this package is going to be the base for several different programs,
like what?
Say a server, a command line tool, and maybe an admin migration tool, that's when you need to break from the default and pick XC or src.
So it's all about planning for that complexity down the road.
Exactly. Imagine a big integrated service. Instead of jamming 3 programs into one giant app directory, the strategic move is to use a structure with a top-level X directory.
And inside that?
Inside that, you organize by function. You'd have exaserver main.hs, exaclient main.hs, and examigrate main.hs. That kind of organization immediately tells anyone new to the project what's going on, and it keeps all the logic separated cleanly.
That makes so much more sense for a larger code base. It's about clarity, really, and just reducing confusion as things scale.
It is. And for anyone wondering why Cabal even has 3 options, app, exe, src, exe, when they look so similar at first, it's mostly historical baggage.
Legacy reasons.
Yeah. Haskell projects have used different folder conventions over the decades. Cabal just keeps these for compatibility. But for any new project, the rule is simple. 1 executable, use app. Many, use X.
Structure defined. Okay, let's move to what I think is a much more strategic and maybe higher risk decision.
Yeah.
The language setting, or as you called it, the dialect dilemma.
This is critical.
And it speaks to one of Haskell's great flexibilities, but also a huge potential pitfall.
It really is, because there's this misconception that a single Haskell package is locked into one global language setting. That's not true.
Right.
Cabal lets you define different dialects or language standards for every single component. Your library in src, your executables in app, your tests, your benchmarks, everything.
And when it prompts you, you're not just picking a name, you're picking which generation of GHC features that piece of code is allowed to use.
Precisely. You'll see a whole range of options. You've got 1, Haskell 2010, which is common, but, getting older. 2 is Haskell 98, which is strictly legacy at this point.
And then the modern ones.
Right. 3 is GHC 2021, which needs at least GHC 9.2, and 4 is GHC 2024, needing GHC 9.9 or later.
Let's pause there. What does choosing GHC 2021 or GHC 2024 actually mean? Because just saying modern is a bit vague.
It's the ultimate shortcut. I mean, historically, if you wanted modern features like lambda case or type families, you had to manually list dozens of language pragmas at the top of every file.
Yeah, I remember that.
The GHC 2021 and GHC 2024 standards are just predefined bundles of the most commonly used stable modern language extensions.
So by picking GHC 2024, you're basically saying, turn on the whole modern dashboard of features for this part of the code without having to list them all by hand.
Exactly. It's a huge quality of life improvement, and it forces a defined baseline for your whole team. Now let's focus on the strategic pairing. matching the dialect of your library in JRC with the dialect of your application in app.
This is where we need a solid rule of thumb.
The essential guideline, and this comes from best practices in the community, is this. The application component, so your app dialect, should be as modern as, or even more modern than, the core library it depends on.
Okay, but hold on. If GHC 2024 is the latest and greatest and saves all that typing, why wouldn't I just use it everywhere? I mean, doesn't more modern always win?
That is the core trade-off.
Why bother with something like Haskell 2010 for the library at all?
It's about portability and stability. If you use the most bleeding-edge extensions from, say, GHC 9.0, your library is instantly useless to anyone running an older but still very common GHC version like 8.10.
Ah, okay. So a stable, widely appealing library means choosing a more conservative core dialect.
Precisely. And that makes the strategic pairings from the source notes much clearer. It's all a risk-reward analysis.
Okay, so let's walk through them. First is maximum portability.
Right. For that, you keep your SRI core super stable, maybe Haskell 98 or Haskell 2010, but you let your specific application, the app part, use all the modern features of GHC 2021. The core is stable for everyone, but your app gets the new bells and whistles.
Then there's the conservative core, modern edges approach. That feels like a safe middle ground for most professional work.
And that pairing just shifts the core up a bit. You might use Haskell 2010 or even GHC 2021 for SRC, which gives you a robust modern feature set that still works across recent GHC versions. And your app can stay current with GHC 2024 to get the newest tooling improvements.
The other two pairings are more straightforward, but they have distinct implications. A stable modern standard is just both SRC and app on GHC 2021.
Yeah, that's great if you know your team is standardized on a recent GHC. It balances features and stability really nicely.
And the latest greatest, both on GHC 2024.
That's for greenfield projects where you control the whole ecosystem and you just want the newest compiler optimizations above everything else. But be warned, that's where you hit the steepest portability wall.
Okay, now for the analogy that I think perfectly clarifies the risk of getting this rule wrong. This is the critical insight we need everyone to remember.
Absolutely. The analogy highlights the danger of mismatching the dialects in the wrong direction.
What happens then?
If you try to build your executable using a legacy dialect, let's say Haskell 98 for the app, but that app depends on a cutting-edge library in SRC written with GHC 2024, you run into a huge problem.
The famous 1990s analog dashboard in the 2024 electric vehicle.
That is the perfect illustration. The GHC 2024 library, your engine, is filled with modern features, sophisticated type families, advanced operators, implicit parameters. The Haskell 98 dialect, your dashboard, it was built before any of those things even existed.
So does it have the gauges, the control?
Or even the basic wiring to interface with those modern features. The compiler just won't know what to do.
So the error isn't that the code is bad, it's that the application's entry point is literally incapable of understanding the language used by the library it's trying to call.
Exactly. You've created an incompatibility crisis between the driver and the engine. The driver, the app, has to speak at least the same language as the engine, the library. This is probably the most crucial choice in the whole Cabal setup.
That really settles the major decisions. Now, before we get to the final steps, Cabal throws out one historical option that confuses a lot of new people, and it's a quick detour we need to dismiss. Literate programming.
Ah, yes. When you set up a test suite, Cabal asks you to name the main module. The default is Main.hs, but you'll see another option, Main.lhs.
And that .hs stands for Literate Haskell.
It does, and this takes us way back to Haskell's academic roots over 30 years ago, when the idea of literate programming, or LP, was, well, it was hugely respected.
And the idea behind it?
LP was pioneered by Donald Knuth. It's a beautiful idea, really. The principle is that the documentation, the prose, is the main focus, and the code is embedded within it. It's fantastic for explaining a complex algorithm in a research paper.
But beautiful doesn't always translate to industrial scale or efficiency.
And that's the drawback. Modern development is all about rapid refactoring and tooling. Think about how you debug. You need to jump to a function definition, rename a variable everywhere, run static analysis. Literate programming formats make all of that tooling support significantly harder to implement and use.
So for almost every project out there, unless you're writing a textbook, the recommendation is clear. Just stick to Main.hs.
100%. The slight aesthetic benefit is just not worth the efficiency cost. It's an option maintained for historical context, but it shouldn't be your default choice in a professional setting. Avoid the beautiful distraction.
Okay, so let's wrap up with the final configuration and cleanup. Cabal finishes by asking some minor questions, like whether to include comments in the .cabal file, which is a good default to keep on yes, and the language for the test suite, which usually defaults to a safe standard like Haskell 2010.
Once you confirm those, Cabal generates the standard project structure. You see it in your notes. The admin files like licensee and changelog.md, the .src directory with mylib.hs, the .app directory with main.hs, and a .test directory, and of course the main.cabal file itself.
But the process isn't truly done just because the tool has run. The source material really emphasizes reading the immediate warnings.
Yeah, that's the final act of due diligence. You'll immediately see a warning that says something like, no synopsis was given.
Right.
Cabal needs you to manually edit that new .cabal file to add a meaningful synopsis and a longer description.
And these aren't just busy work. They're vital for package discovery, for documentation, for anyone who might use your package later on.
Exactly. Skipping that step just makes your package look incomplete on a repository like Hackage. And it makes it harder for others to understand what your code does. It's a necessary manual step to finish the job right.
So what does this all mean? We've navigated the structure pitfalls, we've resolved the dialect pairing, we've dismissed a historical distraction.
The key learnings, the things you really need to take away, are focused on setting your project up for the long run. First, choose app versus excree, based only on whether you're building one program or many.
And second,
and this is non-negotiable, you have to ensure your application dialect is modern enough to fully interface with your library dialect. Avoid that analog dashboard problem at all costs.
that foundational setup clarity is just invaluable. Now, as we wrap up, the research notes we looked at had this fascinating final postscript, which, while not about Cabal, speaks directly to this need for critical validation in our work.
Right. The note highlighted the challenge of validating output from really complex systems, and it specifically mentioned that because of the huge resource costs, the performance and even the intelligence of some AI models can fluctuate day to day.
Which led the author to recommend never trusting a single source for foundational technical answers. So for you, the listener, the provocative thought we want to leave you with is to apply that critical validation principle to every source you encounter. Not just the answers you get from a machine, but even the defaults you accept from a tool like Cabal.
Yeah. Cabal gives you a working project, but it also gives you warnings and legacy options.
You have to read the fine print, validate the choices, and use your informed judgment to make sure you're not just accepting a default, but actively building a robust foundation. That informed judgment is the final, most crucial step in any deep dive.